Hello everyone and welcome to Mathics. In this video, we're going to focus on SASMO Grade 9 questions. You could find the download link in the description box below. The reason I'm making this video is to see how many people are interested in SASMO questions. Okay, if you're one of them, please let me know in the comment section below. You could also tell me what grade you want the questions for or what year you prefer. So basically, let me know, because if I see a lot of people are interested, then I'll keep making more questions and more solutions for different kinds of tests. Okay, so let's just start and start answering these questions, question 1 to 10. Okay, let's do the first question. Arrange these numbers in ascending order. That means from the smallest to the biggest. Okay. So to do this question, you just need to know the power rule, okay? That a to power of m, again to power of another number, okay, will be the same as a to power of, okay, mn, okay? So this is crucial to do this question, okay? So let's do this one. This is really small, okay? So 4 to the 6th power. Okay, we know that 4 is also equals 2 to the 2nd power. Okay, and this 6 will be copied and pasted here. Okay, the same one. So now, according to this rule, we just need to multiply them. So this is the same as 2 to power of 12. And you could easily see that this one is the smallest number, right? Why? Because this one, 2 and 2 are the same, the bases. This one has a larger base, 18. This one is 12, smaller. 3 to the power of 12 and 2, you see that now the powers are the same, but 2 is a smaller. So 2 to the 12th power, okay, is the smallest one. Okay. But now we need to decide, okay, for these two, okay, how to do that, okay. I think the trick is to making the powers the same, okay. Bases will be different, but the powers will be the same, okay. I know that if I divide this one 12 by 2, it will be 6. Okay. If I divide 18 by 3, it will be 6 again. And this is useful. Why? Okay, let's see. Okay, 2 to power of 18th. Let me just make it a better color. So 2 to power of 18. Okay. So I want to write it. I said we need to divide this by 3. Okay. I will write it as 2 to power of 6 times 3, which is going to be this part. And then I could write this as 2 to power of 3 to power of 6. Okay, that means our m was 3, n was 6. Okay, so now one of the numbers is going to be like this, and 2 to the 3rd power is 8. So this number is going to be the same as 8 to the 6th power. Let's do the same thing for the other one. 3 to power of 12. Okay. Again, I could write this as 3 to power of 2 times 6 or 6 times 2. Of course, not different. Okay. So again, this 2 will go inside. I'm going to write it this way. 3 to power of 2 is 9. So this number is 9 to power of 6. So this number, the second one, is 9 to power of 6. Of course, it's going to be like this now. A to power of 6, 9 to power of 6. Okay, because the powers are the same. This base 9 is larger. But 9 to power of 6 was 3 to power of 12. This one was 2 to power of 18. And this one was 4 to the 6th power. Okay, that's the final answer. So let's do another question, question 2 now. Okay, let me remove the edges. Okay, question 2. The Fibonacci numbers are 1, 1, 2, 3, 5, 8, 13, where each term after the second term is obtained by adding the previous 2 terms. How many of the first 2014 Fibonacci numbers are odd? Okay. So let's see it here. The first one is, okay, odds, I'm going to show them by O. Okay. This one is also odd. Even numbers, I'm going to show them by E. This is even number. Again, 3 is odd. This one is odd. This one is even. You see, odd, odd, even, odd, odd, even. Is that an accident? No. Why not? Because, look, when you add 2 odd numbers, you definitely get an even number. Okay. And then for the next one, you add 1 odd, 1 even, it becomes odd. Okay, again, then you will have 1 even, 1 odd, you get odd. And lastly, when you add 2 odd numbers, you get an even. So the same thing will go on forever. So for every 3 numbers that we separate, 2 of them are odd. Okay, so is 2014, if we could divide it by 3, we will find how many groups are there. From each group, 2 of them are odd. Okay, can we do it? No. Why not? Because 2014 is not divisible by 3. 2 plus 0 plus 1 plus 4 is 7, not divisible. But if I make this 2013, then it will. So that means I'm going to go a lot of groups, but 1 number will be left here. And you see, the beginning number, it was always odd. So we have a lot of this. The first 2013 is here. And then will be 1 odd will be left. Okay. So how many groups is there? 2013 divided by 3. Okay. It's not going to be 600. 71. Okay. Multiplied by 2. Okay, is going to be 1342. Okay, so now 1342 are for these ones, but this one needs to be added to it. So plus 1. So the final answer, 1343. Okay, let's do question 3. We're going to solve this equation. So as you see, this is repeating infinite times, right? So it's weird, right? So how can we deal with this? I think it makes sense to square both sides, but will it help? Let's see. Okay, it's going to be this one will be x. But again, the same thing will repeat. Like, okay, we dealt with one of them. Now what happens to the rest of them? X plus, again, a square root of x. And then the same thing goes on here. The right-hand side will be 16. So now x is here. The same thing is repeating. What to do now? Well, I think if you see something happening infinite times, right, like this, it always makes sense to assume that it's something else, right? So if this is t, okay, and you see even this one is repeating infinite times, right? So this is also t. And look at here, we said t is 4. So this is also 4. Genius, isn't it? So x plus 4 equals 16. So x is 12. Okay. Question 4. Find the smallest whole number that leaves remainder of 1 when divided by 3. Okay. So we need a number when we divide it by 3, it becomes 1. So I'm going to write this number as 3k plus 1. Any number that is like this, when we divide it by 3, leaves 1. Like, let's write some of its examples. K is 1 is going to be 4. K is 2, it will be 7. K is 3, it will be 10, and then it will continue like this. Okay, the next number, when we divide it, leaves a remainder divided by 3. A remainder of 2 when divided by 5. The next number, okay, I can't put k here because, well, I'm going to just change it here and write k prime instead of it. It's going to be plus remainder of 2. Okay. So this number, if we start from k0 or k1, it will be like 7. Okay, and then k is 2 will be 12, 17, and so forth. The last one, when we divide it by 7, gives a remainder of 3. So like what? It could be, it's going to be 10. Okay. If it's 2, 17. If it's 3, 24. Okay. Now, these will continue to a point where all of them will get to one number. Okay. So you see, for example, here, 10 and 10 is good because it's on this list and on this list, but not here. Okay. So I think the easiest way is to continue, so do some guesswork and continue this larger one, right? So I'm going to just keep adding to this list. So plus 7, this one will be, you see, I'm just adding 7 each time, 31. When 31 divided by this one will give remainder of 1. For this one is okay. This one will get to 31, but not this one. How about 38? 38, when we divide it by 3, it gives remainder of 2, not good. So 45 is divisible by this, definitely not good. So how about 52? It works with this one. And it works with this one too, right? You could try it. So 52 is the right answer. When we divide it by, if k prime is 10, then it will become 52. For this one, if k is 17, it will become 52 again. So 52 is the right answer. Let's do question 5. Evaluate this expression, right? The numbers are very confusing. 2014, 15, and then blah, blah, blah. Okay. Now, if you just want to write them there, and I hope you know that you need to factorize them and then cancel stuff. So, but each time you write one of these, they're 8 digits. It takes a lot of time. And on top of that, you might make a mistake and then get the wrong answer. So what to do? You just have to name these, right? So I'm going to find, this is the smallest number, 2014, 2014. I'm going to call this one anything. I'm going to call this X. 2014, 2015 is only one more than this. This is X plus 1. Okay. Well, let's do the same thing with these. Which one is smaller? This one is smaller. I'm going to call this Y. So this one is Y plus 1. Okay. So now instead of writing these weird numbers, we're just gonna write X and Y. It would be so much easier. So let's multiply these. Let's write it like this. It wouldn't be confusing to anyone. So this is what we're going to do. We want to simplify this. Now, y will be multiplied by both of them. It will be x, y, plus y. Okay, minus. Remember, this minus, it was for both of these. So I'm going to write it here. Minus xy when we multiply it. And you see x is plus here. It will be x. But you see that this minus belongs to both of them. So it will be xy plus y minus xy minus x. And now you see that xy's are canceled. All you have to do is find y minus x. Now, y is this one, 2, 0, 1, 5, 2, 1, 4. Minus by x, 2014, 2014. Okay, so what we're gonna get is just minus these two numbers, 0, 0, 0, 0, 1, 0, 0, 0. So the answer is 10,000. Easy peasy. Question 6. If this expression, we call it x, what is this? Again, in terms of x. Okay, so that means we have this. We need to find this with it. Okay. So, but there is a problem because here we have 3 here. And I see no 3 here. And it's just that makes it difficult. Okay. But let's see here. I want to write it this one like in fraction form. This is going to be 1 over 4 plus 1 over 60 plus 1 over 36. Now I want to write these. This is 1 over 4 plus 1 over 9 plus 1 over 16. This will be 1 over 25, one more term. Okay, this one, let me add more to it. This would be 1 over 64. So now what to do? There is a little thing, okay? And if I want to continue this, the next one will be 1 over 10. 10 squared, it will be 1 plus 10 squared is 100. But now I want you to pay attention that this one with this one, okay, this one and this one, what is the relationship between them? And now, let me change color. This one and this one. Also, this one and this one. What is the relationship between these? You see, all of them, 1 over 4, all of these have been divided by 4. Okay, so if we divide this one by 4, okay, it would appear just like this one, right? A little different. Now let's do it like this, okay? So this is what we're trying to make. I'm going to write x, but we want to create x over 4. So the first term will be 1 over 4. Okay. The second term will be 1 over 4. And again, another 4, 1 over 16. Okay. And again, this one, 1 over 9, divided by 4, 1 over 36. Which is like this. But remember, I didn't write this one. There was one, this one, I didn't write it here. So this one has to start like this. Okay. So that's pretty good. So this one, x over 4, looks like this one, but this one is lacking. So this one doesn't only have this one. Like, we need to add this. So to both sides of the equation, I'm going to add 1 here, 1 plus 1 here, and 1 plus 1 to here. Now, this and this are absolutely the same. So we expressed it in terms of x. 1 plus x over 4 is the answer. Okay, let's do question 7. Find the exact value of this. As I said before, okay, we're going to call this t, right? Okay, so now what to do? Okay, I noticed that there is a 1 over here, okay? And I want to make it reciprocal, right? The denominator is numerator, numerator, denominator. Okay. We know that any number divided by itself, okay, is itself, right? It's going to be still t. And now, okay, I'm going to make the reciprocal. 1 goes up, t goes down. Let's do the same thing for this side. 1 was up, it will go down. This one, 1 plus the same thing. I'm going to write it like this. Okay, it will be 1 over 1 plus 1 over blah, blah, blah. This is not big enough. Okay, let me also write it again better. Okay. So this one will be 1 over here. This one will be 1 plus. Okay. 1 plus 1 over 1 plus stuff. Okay. So now guess what? You see, now let's go back to what we said. We called this one 1 over plus 1t. So that means all of this is t again. Okay. So, and remember, because here we have 1, any number divided by that is going to be the same thing. So let's clear this. We don't need it. And this one is also t. So the equation turns into this 1 plus t equals 1 over t. Now we know that t can never be 0, okay? So let's multiply both sides of an equation by value of t so that we get rid of this t here. Okay, then what are we going to have? So it will be t plus t squared equals 1. Now let's take 1 to the left side. It will be t squared plus t minus 1 equals 0. Now this is a quadratic equation, right? Not very difficult to solve. So I hope you know quadratic formula. So this was A, this was B, this was C. So now the left term is going to be negative B. B is 1, negative B is negative 1. Okay, plus minus square root of 4AC, 4 times. Okay, wait a second. B squared, 1 minus, okay, 4, B squared minus 4AC. 4A and C is negative 1. So it's going to be negative 4, okay, over 2. So the answer will be this one. It will be negative 1 over 2 minus square root of 5 over 2. The other one will be negative 1 over 2 plus 5 over 2. So we have two solutions for this equation, but only one of them is acceptable. Why is that? Let's see here. See, t here is 1 over 1. Is always, everything here is positive. But this value is negative. It will never work. So this one is out. But this one is a positive value. Look, this is more than 2, right? So this divided by 2 is more than 1. Divided by half, this is positive. So the right answer, we could also write it like this. Square root of 5 minus 1 over 2 is the right answer. Okay, question 8 will be a little long, right? So I've decided to make a separate video on this question and put it in the channel, not here. So if you're interested, you want to know the answer to this question, make sure you're subscribed. In the next couple of weeks, I will make a separate video on this question and put it in the channel. Okay, question 9. This is the definition of factorial, right? Nth factorial. Okay, if you don't know, this is the meaning of nth factorial. So find the last digit of this. Okay. So 1 factorial is 1. 2 factorial is 2 times 1 plus 2. 3 factorial is 3 times 2 times 1 is 6. 4 factorial is 4 times 3 times 2 times 1 is 24. 5 factorial is 24 times 5 is going to be 120. 6 factorial is the same as 120 multiplied by 6. 720. Okay, and now let's see. Next, we have to multiply this by 7. Okay, but guess what? This number already has a 0. So the next number, 720 multiplied by 7, is going to be blah, 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 0. Okay, and we want the last digit of this. Okay, so to find the last digit, okay, the units digit, we don't care about these, right? These zeros, they have zeros. So we just need to find these digits, right? 24 plus 6 plus 2 plus 1 gives what digit, okay? So these numbers will be 33. So the last digit will be only 3, okay? These numbers will only add zeros here, 0, 0, 0, 0 here, which are not going to have an effect on the last digit. Okay, the last question. Okay, let x be a number such that find the value of this, okay? So if you want to solve x, solve for x. And then take it like here, really bad idea. It will take forever. Instead, we just square both sides. And we know, I hope you haven't forgotten, a plus b squared equals the first term is squared plus the last term is squared plus 2 times ab, right? We're going to just use this formula here. Okay, so let's write this one. When you square it, it will be the first term is squared, the last term is squared, and plus 2 times of first and last, 2 times of, look, it's going to be x multiplied by 1 over x, which guess what? These two will be canceled. So we're going to have x squared plus 1 over x squared plus 2 equals 5 squared, which is 25. So the value of this x squared plus 1 over x squared is going to be 25 minus 2, which is 23. Okay. So let's use the formula one more time, and then we get the answer. Let me change color. Again, the first term is squared, x over to the 4th power plus. And again, you saw that they will be canceled. It will just be plus a 2 equals 23 to the 2nd power. Okay. 460. 23 will be 460, okay, plus 69. Okay, would be 529. Okay, so this side will be 529. So if this is 529, okay, but we want this value, so 2 will go to the other side, or both sides minus by 2. Okay, so these two will be canceled. Oops. So you get the idea. I made a little mess here. So let's see it here. Okay, so this value, let me clean it. The answer is 529 minus 2. So the answer will be here. 527 will be the right answer. Okay, so before you go, I want to show you all the solutions here, so that you would see it here in a graph. Let me just do some cleaning here. Okay. So end of paper. All right, these are the solutions we had. Okay. Question 8, we didn't do. I'm going to do it, but this is the final answer in case you want to give it a try. So 3 and 527. That's the end of our video. Okay, don't forget to tell me what tests, okay, what level you want me to make solutions for. So make sure you subscribe, and I'll see you in my next videos.